All right, section 4.2, we're going to talk about trigonometric functions of acute angles. And remember that word acute, what that means is the little angles. Whenever we have an acute angle, it is less than 90 degrees. Hang on. Okay, that's what acute means. And the way you can remember that is you go, oh, look at how cute the little angle is, because it's acute. Okay, so less than 90 degrees is what we're talking about. And this is called right triangle trigonometry, and this should be at least a little bit familiar to you from geometry, at least some of it. It's based on angles in standard position on the xy coordinate plane. So an xy coordinate plane is, where we have an x and y axis, right? The right triangle we look at will be formed with the x-axis and a perpendicular line to the terminal side of an angle. So what we do is we draw our angle here, and then we follow this line out somewhere, and then just at some point, it doesn't really matter where, we draw down to the x-axis a line that will end up making a right angle right here. Okay? So this is now a right triangle, because if it's a right triangle, then we're allowed to use sine, cosine, tangent, and all those trig functions to figure out what the different parts of the triangle are. So whenever we have it in standard position right here, and it's in the first quadrant, always draw down. Never draw to the left, always draw down. The reference angle will be formed with the x-axis and the terminal side of the angle. So this right here, we use theta a lot to describe angles. This right here is our angle theta. And so it doesn't really matter what theta is, we can find all the parts and we can talk about all of the trig angles related to that. How do I stop recording?
Command Shift 2. Hey, okay, let's look at some examples then of basically your basic of all basic trig functions.
Yes.
The basics. Like, you need to get these committed to memory.
Right, because they're like the foundation of trigonometry. They are the trigonometric functions, right?
Yeah.
Okay. So,
and they're going to be awesome.
In this section, we're only talking about theta being an acute angle, like we talked about on the first slide. And so
acute as opposed to ugly.
Right, right. And so that you could say, oh, look at that acute angle, because it's less than 90. I did that on the first slide too.
Okay.
But you were
okay.
All right. So sine, we spelled out sine for you there, so that you know how to actually spell sine. It's not actually sin. It's sine.
No, don't get this confused with the devil. It's
not
from the devil. This is totally from the heavens above.
Or
the math gods.
Yes. Okay. Sine of theta, we abbreviate that as sin theta. That equals opposite over hypotenuse.
Right.
Cosine is cos, adjacent over hypotenuse. Tangent is tan, opposite over adjacent. That should look familiar from geometry. You might have had a way to remember that, which was SOHCAHTOA.
Oh, there's
Everyone
another.
has their favorite.
What? You know what?
Yeah.
Don't mind if I do, but you can also do it this way. So. Toa.
And that's the same thing, just it helps you remember that this is a fraction.
The appropriate order.
O and H,
oh,
yeah. So then there's other mnemonic devices to remember it, like
some old hag canned a half ton of apples.
Yeah, there's that
Some
one.
old hippie caught another hippie tripping on acid.
There's that one. That's all I know.
That's the only ones I know.
Okay. So, and then cosecant, secant, and cotangent you may not have seen before. And what these are the reciprocal functions of sine, cosine, and tangent. Sine and cosecant go together.
Right.
Cosine and secant go together.
Right.
Tangent and cotangent go together. Now these should be easy to remember because one's tangent and one's cotangent. So like they're like of each other.
Right.
Okay. Now the way I remember the other ones is that it's opposite of what you would think, like S and C, C and S.
Right. That's exactly how I remember.
Cosine and cosecant don't go together. Okay. Don't put those together.
Yeah. Cos don't go.
Yeah. So cosecant.
If it's co, it don't go.
Okay. Hypotenuse over opposite. Notice that's the opposite, like the reciprocal thingy of opposite over hypotenuse. And so what we'll end up seeing, and so whenever you put this in the calculator, if you have a non-inspired calculator, you'll need to know this at some point. Like to put in cosecant, we do 1 divided by sine, because cosecant is the reciprocal of sine.
Right. It is not the -1, sine of the -1.
No.
That is a different animal altogether. Don't make that mistake.
Yeah, so this is how, if you're putting it into the calculator, this is how you would put these in. Unless you have the Inspire. The Inspire has cosecant, secant, and cotangent buttons.
That is correct, yeah.
Which is pretty nifty.
Then you just have to pay attention to make sure that you're in degrees and radians.
Right, but we'll get there.
Right.
Okay, find all 6 trig functions for an angle of 45 degrees. Now, okay, so, sorry. Find all 6 trig functions for an angle of 45 degrees. Should I stop? Okay, find all 6 trig functions for an angle of 45 degrees. Now, I believe that that's considered a special right triangle.
A special.
A special right triangle.
It's usually referred to as a 45, 45, 90 right triangle.
Yes.
Yes.
Because the angles are 45, 45, and 90.
That is correctamundo. Yes, indeed.
Okay, well.
That's a brilliant triangle.
Thanks. So we're going to stick, this is a 45 degree angle.
There.
90.
90 and 45 up there. Yes.
Okay,
Excellent.
so
Very well done.
What are the sides of a 45, 45 degree 90 triangle?
An X. 1. 1. You want to go with 1 and just see where it leads us?
Yeah,
okay.
If this side is 1,
okay,
and these are both 45 degrees, then that means this side has to be 1 as well.
yes, and then we can use the hypotenuse of the right triangle, good old Pythagorean.
Pythagorean theorem.
Yeah, that was what I was going to say.
To see 1 squared plus 1 squared equals
Square root of 2.
Square root of 2.
So the hypotenuse is the square root of 2.
Now, we just derived that and showed you where it came from. We picked the first side and then came up with what the other two would have to be. And so you need to now commit this to memory if you haven't already, because you talked about it in geometry.
Yeah.
That the sides of a 45, 45, 90 are 1, 1 square root of 2.
Right.
It'll make your life
every
a lot
single
easier.
time. Yes.
And the reason that we're allowed to pick whatever number we wanted to start off with is because if we're talking about the sine, cosine, and all that of the angle 45 degrees, I guess I could put 45 degrees instead of theta. Sorry. We're talking about sine of 45 degrees. It doesn't matter what sides we start off with because it's a ratio of the two sides opposite over hypotenuse.
And they're both the same.
Yeah. So this equals 1 over square root of 2. You mean by both the same? You
The
mean
two sides there are both
yeah.
the same.
Oh, yeah. 1 over square root of 2. Now, are we okay with this answer?
I'm okay with that answer.
I'm
you
okay
okay
with,
with that
I'm
answer?
okay with that answer.
But you know what? There's probably going to be a college professor in your future that isn't okay with that answer.
Right. So
Just
let's talk about rationalizing the denominator. If you have a square root on the bottom, you would times the top and the bottom by what that square root is.
Right.
So we would, let me just change colors here. We would multiply by square root of 2 on the top and the bottom. What is that? Okay.
That's a square root of 2.
And so that's 1 times the square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. So 2 square root of 2 over 2.
And usually the answers in our book, if you are to like do some investigating, this is typically the answer that you'll get.
Right. They rationalize in our book a lot. But you don't
But if you're taking
necessarily
an
have
AP
to.
exam or something like that, you can leave the radical in the denominator.
Right, right. Cosine of 45 degrees, the adjacent side over the hypotenuse is 1 over the square root of 2.
It's the exact same thing.
So 1 over the square root of 2 or
square root of 2 over 2.
Tangent. Tangent of 45 degrees is probably one of my favorite tangents.
Gosh, you know why?
Because it's 1 over 1, which is 1?
Yes.
Yeah, beautiful.
I mean, it just rolls off the tongue. 1 over 1 equals 1.
Yep, 6 trig functions. So now let's do cosecant, secant, and cotangent. So even if you rationalize these, it's really helpful to write them unrationalized first because you have to realize cosecant of 45 degrees, flip 1 over square root of 2.
That's just square root of 2. There's no rationaling.
You don't have to go back to the triangle unless you didn't,
not at all.
Didn't do it right the first time or whatever. Secant of 45 degrees is also square root of 2 because you flip this right here.
Right.
Cotangent, what do we get if we flip 1?
The reciprocal of 1
is
0.
1.
Okay, that's what my second guess.
Which is 1.
Okay,
all right,
good
there's
talk.
the 6 trig functions. Now let's do 30 degrees. Now that's a special right triangle as well.
That's also a special right triangle. And oh, by the way, you're going to see these angles a lot in your future. And when I say a lot, I mean
like when we say commit it to memory, we really mean commit it to memory. Because if we walk up to your desk and say, hey, you know those special right triangles, and you're like, then that's not really a good thing.
That's not really it. That's more like a 60-60-60 triangle.
And that's how we derive it, right?
What?
If we're talking about how to get it,
I don't understand. This is crazy what you're doing right now.
No, it's not.
What?
All right, the way we come up with the special right triangle that's 30, 60, 90 is we talk about an equilateral triangle.
Yes, which is 60 degrees all the way around, which means that all the sides are the same.
Right. And so we say, well, that's 60, that's 60. Up here at the top is 60, but we're dividing it in half, so this is where we get our 30 degrees from.
Right.
Okay, now, in this case, I think we should start off with all of the sides of this equilateral triangle being 2.
If you say so, I'll agree, because...
Why not?
Yeah.
Yeah. Okay, well, if we're just looking at this half of our equilateral triangle, we divide it in half, so that means that this side right here...
Got to be a 1.
Right, so that's why we picked 2, so that we wouldn't start off with a fraction.
Yeah, that's good thinking.
Yeah, so then we have to use Pythagorean's theorem again to figure out the third side
But
here.
in reverse, though, so we have the hypotenuse, we are missing a leg.
So we do the hypotenuse minus the leg,
So
both of those squared and square rooted.
Right.
So that's 5 minus 1, no,
4
4 minus
1,
which is 3, so square root of 3.
Right.
So this third side over here would be...
Square root of 3.
Yeah, just get rid of that.
Wow, there it goes. It's gone. It's like the trash.
Okay, so now let's find the 6 trig functions. Notice we're going from 30 degrees. So this is our reference angle, is this 30 degrees up here. So maybe I should have drawn the triangle a different direction.
That's okay, but we're good. We're good.
So sine of 30 is
The
opposite over hypotenuse. So
which
that's
is 1 over 2.
1 over 2.
Easy enough.
Cosine of 30 degrees.
It's going to be the adjacent over the hypotenuse.
So square root of 3 over 2. And tangent.
It's going to be opposite over adjacent.
Which is...
is that going to be 1 over the square root of 3?
1 over the square root of 3.
Oh, we've got a radical in the denominator again.
So if we want to rationalize that, we would times the top and the bottom by the square root of 3.
Square root of 3 over 3?
Square root of 3 over 3.
Look at that, we're geniuses.
Yeah, it might be helpful for you guys to go ahead and practice, at least in this section, rationalizing, just to see what it feels like, just to get in the groove, and then later on, if somebody makes you do it, you won't be totally unprepared.
Right.
The reciprocal of 1/2 is 2. Secant of 30 degrees. The reciprocal of square root of 3 over 2 is 2 over the square root of 3. So rationalize that.
2 square roots of 3 over 3.
Right. 2 square roots of 3 over 3. And cotangent?
Would be square root of 3.
Right, because remember, it's better to flip this one than this one.
Right.
1 over the square root of 3 becomes square root of 3 over 1. So that's finding all the 6.
Hey, now hold on. But the wait, there's more.
There's more?
There's more. If you act now, then you will notice that maybe the sine of 60 is everything in reverse.
Like if we did this with 60 degrees
Yeah, if we did
instead?
this with 60 instead.
So we just, for the opposite over hypotenuse, if we were talking about 60 degrees instead, we
It
have
matches
square root of 3
cosine of
over
30.
2.
Look at that. Look at that right there.
So we're saying that
It's 2 for the price of
that
1, sort
sine of 30 degrees equals cosine of 60 degrees?
That is correct. Isn't that sick?
Sickly awesome?
Yes.
Sure, why not?
Yeah, wicked. Totally wicked.
I bet that's going to come up at some
I
point.
bet it comes up. Yeah.
Okay.
Stay tuned.
Okay. Example 3. Let theta be an acute angle such that sine of theta equals 5 over 6. Find all the other trig functions of theta. What do you think we should do?
Draw a triangle.
Draw a triangle.
Basically, one of the things that will help you survive trig while you're drawing the triangle. One of the things that's going to help you survive trig is drawing out exactly what you are told. So if they give you a triangle of some sort, stink and draw that sucker out and get a good eyeball on it. It's just crazy important to do that.
Okay, so we don't know what theta is, but that's okay. The
all right.
opposite side is 5.
The hypotenuse
is 6.
Yep.
I decided to draw it in like the first quadrant because we had that on the first slide, and I think that's going to help later on when we start putting angles in other quadrants.
That's pretty good.
So
pretty good.
that's why I did that as opposed to what we've been doing. I think that we need to find the adjacent side because as soon as we try to find cosine, we're going to need it.
And it says to find all the other trig functions,
Yeah.
which means that we are going to have to find cosine. So
we do the Pythagorean theorem, which since we know the hypotenuse and a leg, we subtract them. 6 squared minus 5 squared underneath our square root. If you do this on the calculator, take just the part under the square root. 36 minus 25, which is 11.
Right.
And then you write the square root over it. Simplify
you
if necessary.
cannot
Don't
put
tell
this
us
into decimal.
3 point
yeah.
blah, blah, blah.
Right. That's a big old
Yeah,
wrong.
Yeah.
So,
don't do it.
yeah.
It's square root of 11. because that is an exact value.
Exactamundo.
Okay, if you were to put the decimal, you've rounded, and that makes that approximate.
Yeah.
So square root of 11.
Don't build my bridge if you're going to round.
Yes, because then the bridge might fall down
That
because
is
of a
correct.
rounding
Yes.
error. Yeah, totally. That would suck. Square root of 11 over 6. Have you ever, there's this video of this really super wobbly bridge, like from way back in the day.
I've seen it.
I bet that was a rounding error.
That was what happened.
Yeah, it was
Hey, it got out of phase, which has to do with trig
11.
functions.
Yeah. We're
going to have to show that video later.
Yeah, we will.
Okay.
So I was just going through my little identities, adjacent over hypotenuse, opposite over adjacent. Oh, I guess we could rationalize this and make this 5 square roots of 11. Over 11.
Yeah.
That's an 11 underneath that square root.
That's good. Now it's a big blob. It was an 11. Now it isn't. It's, wow. It's like it just undid itself magically.
Okay.
Perfect.
And then we need, don't forget, cosecant.
Secant and cotangent.
Yeah. Cosecant is the opposite of sine, which they told us initially was 5 over 6, so that's 6 over 5. Secant is 6 over the square root of 11, which is rationalized 6 square roots of 11 over 11. Cotangent.
Square root of 11 over 5.
Square root of 11
Go
over
with
5.
that first guy first.
Yeah.
Makes life just...
This one, not this one.
Yeah, right.
All right, so that's all we had to do there. So it mattered what the sides were. We had to find the third side. If we needed to simplify, it's good to practice simplifying, right? Right? So like if you get the square root of 40, well, that's not the way we want to leave that.
Don't leave it that way.
Remember, you talk about splitting it up into a perfect square and whatever's left over. So
4 and 10.
4 and 10. You can take the square root of 4.
But not the square root of 10.
But not the square root of 10. So you put the 2 on the outside for the square root of 4. And inside, you leave the 10. This was a completely random made-up example. Please don't think that this has anything to do with the rest of what's on the slide.
No, it doesn't. Nothing at all.
Nothing
In fact,
at all.
while Ms. Stevenson starts the next one, I'm going to grab a calculator.
Okay, a right triangle with a hypotenuse of 8 includes a 37-degree angle. Find the measure of the other 2 angles and the length of the other 2 sides. So,
make sure your calculator's in degree mode.
I was just about to mention that.
Just be in degree mode.
It really doesn't matter which angle we label as 37 degrees, just that we label one. A right angle with a hypotenuse of 8. It wants us to find the measures of the other 2 angles and the lengths of the other 2 sides. Well, hey, look, that one's a right angle, so that one's 90 degrees. And hey, there's this thing where triangles' angles have to add up to be 180 degrees.
Shut the front door, 53.
So that does make that 53, because either you could do 37 plus 90 and subtract from 180, or you could say, well, I already know this is 90, these two have to add up to be 90, so then you could just say 90 minus 37.
Right.
So this is an answer, this is an answer. Now we need to figure out what these 2 sides right here are. And we use trig functions to do that.
Yeah.
Like
I would have probably labeled it X on the bottom and Y on the other side, because X usually runs left, right, Y usually runs up and down. Just me.
Okay. Now
there you go. Perfect. Okay.
Okay. So down here at the bottom,
that's
let's
exactly
find
how I would have done it.
This is the adjacent side. We know the hypotenuse, so we need to use cosine of 37 degrees. Might as well use the angle they gave you in case you randomly screw up and subtract.
Always use the angle they give you.
Yeah.
Always.
X over 8, adjacent over hypotenuse. How do we solve this? There's like a cross-multiplying kind of situation going on, or just think of it like you're timesing 8 on both sides. Whichever way makes you feel more comfortable, that's what's going on. So 8 times cosine of 37 degrees. And like Mr. Hazelwood mentioned,
6.389. You'll need a calculator.
389.
Now, if you don't...
I was meaning make sure it's in degree mode.
Oh, yeah, make sure it's
How do we know that it's supposed to be in degree mode?
Because it says 37 degrees right there.
So if it says degrees, we put it in degree mode.
Oh, yeah.
And if it doesn't say degrees, we need it in radian mode?
Yes.
That sounds so simple when you say it like that. Hint, hint, wink, wink, nudge, nudge. Like, come on, guys. Degree mode is degree mode and radian.
Yeah.
Okay. And
if you get now, when you're doing this, a real easy check is sometimes if you're not in the correct mode, when you know you should get like a small positive answer, you could get some real wacky, weird negative number. And,
or like some decimals that shouldn't. Why did I just write cosine? That's going to be sine.
Danger, Will Robinson. Danger.
I've seen that movie one time. What's it called? It's like from the 80s.
Robinsons.
90s.
Family Robinson Crusoe.
No, that's not it.
Oh.
What? It's some space movie. So times by
Lost
8
in
on both
Space.
sides. There we go. Times by 8 on both sides. Now, if we didn't know the hypotenuse, we would have to do some fancier algebra here. 8 times sine of 37?
4.814. And there's no need, you can go to the third decimal place. You can either round at the third or truncate, which means cut off. So it just depends on...
4.814 or 4.815.
Yep.
Either one of those answers would be correct.
It's a good answer.
Okay, just make sure you round to 3 decimal places. The more decimals, the merrier. Anything?
Well, no, there's 3 decimal places, period.
All the time.
Yeah, every time.
Yeah.
Yeah, not the more the merrier.
No, not the 3. 3 is the perfect number.
Symbiotic.
3 is not a crowd. It's the perfect
It's a symbiotic relationship.
number.
Yep, it's perfect. All right.
Example 5. Find a point 340 feet away from the base of the Peachtree Center Plaza in Atlanta, Georgia. The angle of elevation to the top of the building is 65 degrees. Find the height of the building.
My brother lives in Atlanta.
That's exciting.
He can watch us on YouTube. Hey, Jeremy.
Are you going to actually send it to him? Or
might
does he
send
just
him a
watch
link.
your channel?
You know, he loves me.
That's really...
In a brotherly sort of.
That's really neither here nor there.
Okay. So, since we need to find the height of this building, draw the picture. I bet the Peachtree Center is fatter than that. Just saying.
I think it's all about perspective.
Okay. Anytime you're asked to do anything in trig, draw a picture. We said that on a previous slide. Draw a picture because you've got to see what's going on so that you can get all the things that you need done, labeled correctly, and put together in the right way. Is he always laying down?
Because they didn't tell us the height of the person.
Okay.
So I'm
all right.
assuming that we have to go from the ground.
Yeah, we'll go from the ground.
So someone's laying on the ground. Angle of elevation means you start flat and then you go up. This is angle of elevation.
You got to look up to get that angle.
Yeah.
An angle of depression, though, is if you're looking straight ahead and then look down, this little angle in here, right here. That's your angle of depression.
So this drawing is not to scale.
Okay.
Because 65 degrees is a bigger angle than that. But that's okay. Your pictures don't have to be to scale.
No, because you're going to do the math.
Yeah, you're totally going to. From a point 340 feet away. So
We know where
this
that
side is 340 feet.
The Peachtree building is going to be really tall.
Yeah, so we want to find this height over here, like H. Let's go
H.
with an H. So
We would, by the way, random citizen, we would love to see the Peachtree building this summer at the ISTE conference. So feel free to sponsor 2 teachers.
okay, nice.
Yeah.
Height. Let's find the height. Tangent is opposite over adjacent, and that's what we have. What am I writing? Tangent of 65 degrees. Hey, what should our calculator be in?
This would be degree mode, by the way, because it says 65 degrees.
Oh, okay. Okay, I
Solid.
see. I see. Okay, so since 340 is on the bottom, we have to multiply both sides by 340. Okay, what does that give us for the height?
729.132 feet.
That sounds reasonable because we
does sound
said
reasonable.
it was going to be tall, 65 degrees, because in reality my triangle should have looked more like this, right? So it makes sense that that side is longer than the side they gave us, so...
And it's also not a negative number, which would be, you know, point of error number 1 to pay attention to.
Right, absolutely. Let's just go straight in and talk
Wow,
about common
calculators.
calculator errors and mistakes. Number 1, using the calculator in the wrong angle mode. Like we said, if you see a degree symbol,
Use degree.
yeah, if you don't see a degree symbol,
Use radian.
okay, using the inverse trig key to indicate cotangent, secant,
The
cosecant.
inverse trig key is the key that says sine -1, cosine -1, tangent -1. We don't know these yet. We're learning them later, okay? So if you need cosecant, cotangent, or secant, that is 1 divided by the appropriate trig function.
Right,
okay?
which we wrote earlier on an earlier slide, so you might go back and look at that if you
Don't
didn't.
do this. All right.
Using function shorthand that the calculator does not recognize.
If you just type it into your calculator, really weird.
Okay, okay.
You know, like...
For example, when we had to multiply, if we were doing sine of 30 degrees for some reason, and we were multiplying that by 8 on your calculator, it opens a parentheses, you put 30 in, you have to close that parentheses and multiply by 8.
Or to prevent that from happening, just multiply by 8 to start with.
Oh, but that was not closing parentheses. That was
Yeah.
really the 4th option. And there may be some other things that we'll come across, but the biggest thing is probably the degree radian and evaluating
Yeah, those are the 2
correctly.
big dogs. Yes.
There we go. Happy 4.2.